See what happens. Okay, so doing net ionic equations, I'm going to go through the quick case again. You want to write aqueous reactants as ions. This is actually one of the hardest steps if you can do this. So let's say I have calcium chloride and I'm reacting with silver nitrate. What are the ions from calcium chloride? What does that break apart to? And so I have to recognize that's a calcium and there's 2 chlorines. That's really, really important to be able to recognize this as 3 different things, right? And then what's the charge of the calcium? So no one's typing. Okay, the calcium is a group 2A metal, so when it forms an ion, it's always 2 plus. The 2A. The chlorine is a 7A, so it's always -1. The silver, and then I have to recognize the nitrate as a polyatomic ion. And so that's really important too. I see some people will break this into a nitrogen and 3 oxygens, and you don't want to do that. It's a single thing. So we find the charges, and then we switch places. Who goes with who when they switch? That's actually the second step. And that's also one of the hardest steps. The switch partners. Metal, you have to join metal with non. That's really important. And you have to have a net charge equal to 0. Okay? And so who's going to go with who here? I see that who's the calcium is going to go with nitrate. It was already with chloride. That's the only way it can go. And silver is going to go with chloride. So how will calcium and nitrate come together? How will they make a 0? Can you guys see this? Okay. We got 17 people now. All right. So I guess I'll just keep chatting away. No one's commenting. So I'm guessing this is fine. Or maybe you're watching YouTube. I hope you're not. Okay. So anyway, so calcium's 2 plus, nitrate's minus. So I'm going to need 2 minus 1s to go with 1 plus 2. That's CaNO3, 2. And then the silver and the chloride are both +1 and -1. Now remember, I have to put the metal on the left. And if it's +1 and -1, it's just 1 to 1, AgCl. And so I'm going to ignore that coefficient of 2. Then after that, I'm going to balance with coefficients. Okay. And so I guess what I'll do is I will write the skeletal equation. So these are the products. Those are the reactants. So now CaCl2, let's put it, these guys are aqueous, plus AgNO3, also aqueous, because those were reactants, they were given to us, goes to CaNO3, 2 plus AgCl. And so nobody's saying anything. So we're going to balance. And it looks like, well, the metals are balanced. Calcium 1, 1, silver 1, 1. I have 2 chlorides here and 1 chloride there. So I'll put a 2. And when I do that, now I have 2 silvers. So I'll put a 2 over here. And now that gives me 2 nitrates. Let's balances with the 2 nitrates. So now I have a balanced equation for, I'm going to find the states of the products. And when I've done that, I have a balanced equation. Right? And so, and also we should note that you're going to use a solubility table. In the video lectures, I talked about other cases like an acid-base neutralization and a gas forming, but we've really ignored that for the lab. So for this lab, you're going to use a solubility table. And so in this case, I'm going to realize that this one is soluble because nitrate is always, and in this case, this one is insoluble. That chloride is usually soluble, but not with silver. And so I basically just rewrite the whole thing. CaCl2 aqueous plus 2 AgNO3 aqueous goes to CaNO3 2 aqueous plus 2 AgCl aqueous. Okay, then step 5 is write all aqueous as ions and leave gas, liquid, solid, quote, as is. Right, so in this case, this is kind of difficult like we did up here. We have to break them back into ions again. I've already done this one, and I've already done that one, except there's a 2 in front. So that would be calcium chloride, whoops, calcium 2 plus aqueous plus 2 chloride minus aqueous plus, now I have 2 silver plus aqueous plus 2 nitrate minus aqueous goes to, this is also aqueous, so this would be calcium 2 plus aqueous plus 2 NO3 minus aqueous. I'm going to put the silver down below. Now this one, oops, that one's not aqueous. Whoops, that's supposed to be a solid. I said insoluble. Okay, so the silver 2 AgCl, solid, not broken apart. Okay. 6, write all aqueous, leave gas, Okay, so 6 is cancel out spectator ions. And so in this case, these are what are the same on both sides, meaning probably aqueous. And so if let's do this in red. So it looks to me like calcium was aqueous and the 2 nitrates, they were just floating around. They didn't form the solid. Step 7, write what's left and cancel out common denominator. Common denominator. So in this case, what's left is 2 chloride aqueous plus 2 silver plus aqueous goes to 2 silver chloride solid. And so in this example, there's a common denominator of 2. So I'm going to divide that out. And then 8, what's left, equals the net ionic. And so that would be chloride minus aqueous plus silver plus aqueous goes to silver chloride solid. And that's kind of the final deal. Are there any questions about this? So there, I've linked lots of Khan Academy videos for this. I've also linked my own videos from the earlier lab lecture. We could do an example of, could I use color codes to appreciate the process? Oh, okay. You guys don't see the red here. Can I use green or black? I'll use black. Okay, black. Oops. Let's make it black. Okay. All right, and I guess the only reds, other reds I have was this 2 here. And this one's soluble because of NO3 minus, and this one's insoluble. Let's just say from the table. Okay, is that easier to see? Okay. Yeah, so so this, let's go over that. Let me stop the recording.